In the last lecture, we applied Coulomb's law in a given situation. Let's take another situation today and try to figure out what's going to be the net force on charge 1 because of another charge which is placed at an angle. So let's take a situation wherein, suppose we have Q1 again at origin. We have placed another charge which is Q2, right? So we take the same values. Q1 is equal to 1.6 times 10 raised to the power minus 19 coulombs, and suppose this Q2 is equal to plus 3.2 times 10 raised to the power minus 19 coulomb. Now this is placed, these two charges are placed on x-axis. All right, and then we have another charge which is placed, suppose somewhere here. So this charge is here, and the charge is, suppose we take Q4, and the charge on Q4 is equal to minus 3.2 times 10 raised to the power minus 19 coulombs. All right. This angle, so if you join Q1 and Q2, straight line, we join this angle is 60 degrees. This is angle theta, and this is equal to 60 degrees. So if you consider the force on particle 1 because of Q2 and force on Q1 because of Q4, so we add up this and we are interested to find. So the question goes like this: find F, the net force on 1 because of this system of charges. We have already evaluated in the last lecture. So if you haven't seen my last lecture, visit lecture number 5. Then you will be able to figure it out how we approached this problem, wherein we found what is the Coulomb's force, electrostatic force between Q1 and Q2. So if you want to find what is F1 net, we have to vectorially add these two forces. That is force on 1 because of 2 plus force on 1 because of charge particle Q4. So I have denoted that as, because of this is 4, this is 1, so it is F12 plus F14. So these are the notations that we have used. Now let's see. We already know what is F12. So in the last lecture we evaluated F12. I'll write the values. It was 1.15 times 10 raised to the power minus 24 Newton. And the direction was towards negative x-axis. So I have placed negative I cap, so negative is here, showing the direction is in this direction. So F12 is in this direction, and F14, that is what we are going to figure it out. So this is the situation. Let's see how do we approach it. So if you want to find what is F14, the magnitude of F14. So let's place the values applying Coulomb's law. We get magnitude is 1 over 4 pi epsilon naught, which will be Q1, Q4 divided by, and this is the distance. So let's mention the distance again. This distance is 3/4 of R, and the distance between Q1 and Q2 we have taken R, and in the last lecture, if you remember, the R value was 0.02 meters. So with this information here in the denominator, then we'll have this value 3/4 R whole square. Whatever comes, we need to calculate that value. So this comes out to be, placing the value 1 over 4 pi epsilon naught, it's going to be 9 times 10 raised to the power 9 Newton So this is the value K, right? So if you make the subject of the equation, it will be Newton meter square over Coulomb square times Q1. So the charge on Q1 is 1.6 times 10 raised to the power minus 19 Coulomb, and the charge on this Q4 is given 3.2 times 10 raised to the power minus 19 coulombs, and it's a negative charge. So let us indicate the direction as well. So Q14 direction should be in this direction. It should show what is Q14, right? So it's going to be the attraction. These are of opposite nature. Q1 is given, the value of Q1 is given minus 3.2 times 10 raised to the power minus 19, and there's a distance I've mentioned, and the direction is so I'll just write it more clearly here. Let me write it here. So Q4 is negative, so the direction of F14 should be in this direction. So one is in this direction, one is in the other way, and we are just taking the magnitude of it. So this comes out to be, in the denominator, it comes out to be 3/4 times 0.02, everything squared. Now let's calculate this. It's going to be somewhat 1.6 times 3.2, this divided by 3/4.02, okay, all right. So this comes out to be approximately, if you put in the values there, we evaluate this to 2.05 times 10 raised to the power minus 24 Newton. This is the value of F14. This is the value of F14, the magnitude of it, right? And now we are interested to figure it out, what is F1 net. So therefore, one more thing. Now F14, can we add it vectorially to this, right? Can we add this F14 vectorially with this? Why? We have to find F1 net, right? Now F1 net, F14 is not lying along F12, right? So we need to resolve this vector first and find its component. So using we can write unit vector notation. Unit vector notation. Let us resolve F14. Now vector F14 would be equal to magnitude of F14 cos theta I cap. Now the theta is the angle, I cap in this direction, so it will have one component here, one component perpendicular to this. So one component would be this, which will be in F14 in X direction, right? One would be in this direction, which will be F14 Y. This will be in this direction. So one component I've written in this way, plus magnitude of F14 sine theta j cap. This is going to be the vertical component. Now magnitude we already know, cos theta, we know cos theta is 60 degrees, so let me replace that value. Theta is equal to 60 degrees. So now put in the value. So this comes out to be, the magnitude is 2.05 times 10 raised to the power minus 24 times cos 60, which is 1/2. Okay, and this is going to be I cap. So whatever comes, certainly it is in Newton, and plus this comes out to be 2.05 times 10 raised to the power minus 24, and sine 30 is √3/2. All right, so this is J cap, and this is how we get the values Newton in newtons. Okay, so this is what F14 is. Let's go through the steps again. So here what do we do? Here we are trying to figure it out, what is the net force, right? So here we have F12 in this direction, negative x, and F14 is central force, which is directed along Q4. Why? Because Q4 is negative and Q1 is positive, right? So it's a force of attraction. Now this F14 we have to resolve in respective components. So first we have found out what is the magnitude of this force using Coulomb's law. We got this answer, which is 2.05 times 10 raised to the power minus 24 Newton is the magnitude of this force of attraction, electrostatic force of attraction. Having this information, now I resolve this to find its corresponding vertical and horizontal components. And then when we resolve this, one component which is along x-axis is going to be magnitude of F14 cos 60 I cap, and the vertical component will be magnitude of F14 sine 60. The unit is Newton. We place the values, and then we are going to now find the values using a calculator. So let me find what's going to be. So it's 2.05. Okay. All right. So it comes out to be this value, 1. And this is root 3 by 2, so it comes out to be, this is 1.025 times 10 raised to the power minus 24 I cap, and this comes out to be root 3 by 2, it comes out to be 1.775 times 10 raised to the power minus 24. This is J cap, and the unit is Newton. This is what we got, the value of F14 into respective components. So what we need to then vectorially add it. You can take these steps for your reference. So just take note of these steps, and then we'll move forward to figure it out what exactly comes out to be the final value F1 net. This is what we are going to find. Okay. So I'll have to rub it here. So let me just rub this area. So therefore, F1 net is equal to F12. If you remember F12, already we have taken this value 1 minus 1.15 times 10 raised to the power minus 24 Newton I cap. And then we have two components here. One is 1.025 times 10 raised to the power minus 24 Newton I cap plus 1.775, let us approximate to 1.78 times 10 raised to the power minus 24 Newton, and this will be J cap, right? Now I cap and I cap, let us simplify this. So we have to subtract this. 1.025 minus 1.15, it comes out to be approximately 125. So if you subtract this, it comes out to be 0.125, and that remains as it is. So if you take that decimal out, it's going to be 1.25 minus, this is more than that, times, so we will make it 25 Newton I cap plus 1.78 times 10 raised to the power minus 24 Newton J cap. This is going to be the answer. This is going to be the answer for this value, F1 net. So finally we are able to find what is the net force on charge Q1 because of charge Q4, which is placed here as shown, and that makes, this line makes an angle 60 degrees with the x-axis. So here we get the answer, final answer for what is F1 net. Take note of this. We can have another kind of situation wherein we can place one charge and try to figure it out, the equilibrium condition, and then we'll determine whether the equilibrium is stable or unstable. We'll do that in the next lecture, so watch that out in lecture 7. Thank you.